Hello everybody, welcome back to the kitchen table. Sorry it's been a while. I'm going to pick this up today from Stoke Newington in North London. The guy that I picked it up from was a computer programmer who rescued it from a skip. It was last pat tested in '95. It was taken away by Lanc Police radio branch to be fixed. Let's have a look inside it. I'm going to open it up and we'll see just how bad it is. And I'm pleasantly surprised. It's probably the best I've ever seen, but it's still got the battery attached. It looks like it's been lucky. I'm going to pull out the keyboard ribbon connectors, check them over. So the first ribbon came out okay. I don't think you can see that, but the second ribbon is giving me quite a lot of resistance. Can you see the difference between the colour there? Blue tinge to it. I'm going to get a bit of white vinegar and just run it down the inside of those contacts. All I'm doing, just trying to want it to let go. Ah, there we go. If I'd have yanked it, probably wouldn't have made much difference. So I'll figure out a way to patch this up. Let's get the board out and get this battery off. Floppy drive out. This is a memory expansion. Speakers just pop out like that. And it's clipped. So this whole system runs at 5 volts. There's no funny voltages. There's no -5 and 12 and -12. That's the extent of it. We'll check the power supply in a bit. Obviously you've got the ground because it's... What I'm going to do now is take the board out. There we go. Main board is free. Let's go and clean this out with the compressor, clean the board out with the compressor. Back in a sec. I'm going to come in with a gun. But that's the battery. I've lifted up the CMOS chip, the thing that stores all the settings. I've taken off these two keyboard chips and I've lifted up all the little 0 ohm resistors. These are normally completely rotten. So let's have a look under the scope and see what it actually looks like now I've got most of the stuff out of the way. You can see some of them I've had a go at already. So this one, for example. And what I probably will do while I've got these up, I'll thicken those up because they don't look terribly clever. So we'll do those. We'll do these ones down the side here. You can see I've done the ones under the CMOS chip. And then this side is not so bad. These chips didn't come off very easily, although they looked fine. They wouldn't desolder from underneath, so I had to use a wick, which is why I made a bit of a mess here. Once the socket's on, you won't see that. The important thing is that these are all intact, the lines, and they're not too bad on that side. These ones I did thicken up with a little bit of solder. I've now buzzed out all of these chips, or lines for the chips here, patched up. I just showed you these lines under these resistors. I put those back, put 2 sockets on here, put the chips here into my little TL8662 tester, if they work, and then we'll try and boot the thing. We've got a black screen. I get sync pulse but no picture, either on composite or RGB. And just having a look at this board here, wondering whether you can spot the deliberate or not so deliberate mistake. Look at this guy here. Look at the angle of that. That's been soldered on. I don't know what's happened there. So I'm going to take that out and sit it down properly. And then I'm going to check it with a set of OS 3.11 ROMs because I'm not sure these ROMs are any good. Let's see what happens there. Put the 3.11 ROMs in and took off the jumper, and look, maybe this is the issue. Maybe the battery acid here is bridging the contacts. I've got the button to the delete button, or del key, new CMOS chip, and my new RAM chip, ROM chips, 5 volts and ground. And hold down my del button, I get the pink screen of death. So I'm going to take these sockets off, put new sockets on, and see how we go there. Taken off the ROM sockets, and I don't think there's anything too terrible happening there. What I'm going to do now is clean those up. I'm going to buzz out all of these tracks, or check them by eye under the scope, to be honest. I don't think there's a lot wrong there. ROMs in the new sockets. Let's try this out. If this doesn't work, I think we're going to have to dig the scope out. So let's see what we get. Okay, so that changed absolutely nothing. I'm still getting a pink screen or a purple screen, which basically means a hardware fault, because it turns the screen purple, then I think it turns it blue and then grey, so it's not even getting that far. And then I think we're going to pop this on the scope and start doing some tests. Okay, so you can see I've got the board set up here. I've got it on an isolation transformer and a 5 volt power supply. So the idea here is I've held the machine in reset, which is basically to bridge these two pins. We're going to check the address lines, or the latched address lines. How we're going to do that is on these chips here, 1, 2, 3. So IC29, IC30 and IC31, and we're going to go from pin 12 to 19 on that one, 12 to 19 on that one, and 12 to 15 on that one. And what should happen when we do that is that the frequency will half. You'll see a square wave, and each time we move up one address line, the frequency will half. Okay, so that's pin 12, IC29. That's pin 13. That's pin 14. That's pin 15. That's pin 16, so it's doubling each time. So I have to keep adjusting it. Pin 17. I'm going to just do a few tests here. First one is the RAS, and that's on resistor 133. You see that's there. CAS 0, 1, 2 and 3 are not there. R129 is stuck high. R130 stuck high. R131 stuck high. R132 stuck high. I think that's something to do with the fact it hasn't initialised the ROMs yet. Okay, just showing you that it has got a system clock of 21 MHz. That's on LK28. I'm going to go through the service manual, system failure, point by point. So we've already done the RAS and the CAS. 133 is the RAS, and all of these are the CAS. Check that the reset drive in IC44 pin 44 and IC37 pin 9 is not stuck high. IC37 is the main ARM chip, and IC44 is the MEMC. The pins go counterclockwise from this dot here. This is IC44 pin 44. So it's not stuck high, so it changed there. Now we're going to go IC37 pin 9, and that's not. IC13 pin 29, which is the third one down from here, on, and it goes up. That's correct. We're going to look for the main 24 MHz clock on link 28. Link 28 is the second one in from the left there. Right, so there is our system clock. You'll have to forgive me, I'm skipping all over the place a little bit here. Check for a RAS signal on pin 5 of the DRAMs. I'll do that for all the DRAMs and come back in a sec. So I've got a RAS signal on all of the DRAMs on pin 5. Next part is pretty weird. It says check SK15, which is the expansion port, 27C to be clock 2. What that actually means is 27C, there's 3 rows, A at the bottom, B in the middle, C at the top, and they go from 1 to 32 that way. So 27 is here. 2C means it wants a clock of 2 MHz, 2 MHz, and then we go along one, 8 MHz. So see if it is 8 MHz, and this 29C should be ref 8. I imagine that's an 8 MHz clock. We've got 8 MHz. Now I'm going to check for clocks on the memory controller and on the video chip. Pin 67 on here and pin 19 on here. Yep, definitely got a clock there. 24 MHz, and we've got a 24 MHz clock there as well. So that is a pass. The next point is to try and get all the address lines picked up on the memory controller. So I'm going to go away and scope all of the address lines on here. The same thing with the increasing, or sorry, the halving frequency, and I'll come back. Pin 10, 11, pin 12. Got to admit I'm a bit out of my depth here, but what we've got to do now is probe the data bus. We're holding it in reset still, I think, and the data bus can be picked up apparently on these resistors 49 through 56 or 50, yeah, 65 rather. We're just looking for apparently that it's not stuck high or low. R49, R50, R51, R52, R53, R54. And we've got to check R115 to R128 and R87. So these are these ones here. R115, R116, R17, R18, R19. There's R87. So that appears to be okay. Okay, it's next day now. Back again with the list of things to check on the Acorn A3000. So we got all the way to here. That's what we just did, the data bus. Check for short or open circuits on the DB bus IC43, IC46 pins 12 to 19. That's these two here. And there we go. We've got that's pin 12, pin 13, pin 14, pin 15. It's saying check for short or open circuit. So those weird ones could be open circuit, but they're definitely not short. So I'm going to skip across a few here. Data and address signals on all 4 of the ROMs. They're all there. All of those signals are there. The next test is to check for shorts on the DRAM DRAM bus. That is the short. Yeah. So 28, no short. 29, no short. 30, no short. 31, no short. Check all data signals on IC41. Well, what the before I do that, I'm going to do this one. Check the processor interrupt lines FIO and IRO pins 8 and 7 on the ARM. Neither of these should be stuck low. 7 is stuck low. 8 isn't. That could be our issue, couldn't it? 7 is stuck low. IRO, whatever that is. Okay, so it's next day now. Gave up last night. I've been poking around the IOC. Had a quick chat with Gadget on his Discord, and he's pointed me at this. And in fairness, I should have read this part here. I did the top part, check for the address lines on the MEMC would reset held down. Check for the presence of the latched address lines on the IOC. I didn't do that. I just assumed they were there. So luckily I've got this from last time and I've been over it, and it appears we're missing latched address line 6 on the IOC. I'll show you that quickly. And that's LA2, that's LA3, that's LA4, that's LA5, this is LA6. See, LA6 is dead. Latched address line 6. It appears on pin 16 here. It appears on pin 8 on all of the ROMs. Well, it should appear on the IOC pin 17, which is around here somewhere. It doesn't. It should appear on pin 7 of SK11 here. I don't think it does. And it should appear on pin 3 of IC12 here, and it doesn't. Let's try some continuity. 1, 2, 3, 4, 5, 6, 7, 8. So I'm just going to hold that on there and just swipe down here, because this is where pin 13 is. Nothing. Pin 7 here, nothing. Pin 3 here, nothing. So let's fish out the schematic and see where it could have broken. basically we've got LA6 coming out of here. It goes along here, it goes to all of the ROMs, so you can see it there, LA6 on pin 8, and it's present. We have continuity to pin 8 of all the ROMs. And then it carries on here. And it goes to sheet 2. Okay, well let's go to sheet 2. So here it is coming in sheet 2, latch address lines, blah 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 blah, 20 lines altogether. There's other lines in there as well, but LA6 is what we're interested in. See, it appears here on the external expansion. I haven't tested that, but it probably isn't there. Nothing doing here. It is not present on the IOC. It should be pin 17. Latch address line 6. There's nothing in between this pin here and where it started in terms of components. It's just a wire. So we carry on going along here. We go down here, nothing doing here. We carry along here. We go up here, IC12, well it's supposed to be on pin 3. It isn't, it doesn't appear there. We go along here, we go up here. Latch address line 6 is supposed to be on SK11. It isn't, it doesn't appear there. I'm just going to jumper from this pin, where are we? Pin 7 of the expansion, the internal expansion. I'm going to run a wire literally all the way back to the last place I know it was present, which is on sheet 1, which is going to be either one of the pin 8s of one of the ROM sockets or the pin where it comes out of IC29, which is pin 16. So here's our bodge wire. It's temporary. Because this board's so mint, if this actually works I will go back and try and figure out exactly where the break is, but for now I've just put a bit of tape so it doesn't get ripped off, and I've put it onto pin 3 of IC12 so it's a straight line. So now pin 8, 1, 2, 3, 4, 5, 6, 7, 8 goes to here, it goes to pin 3 here, it goes to there, and it goes to there. So I'll plug this in and see if it works. Sorry for the handheld here, this is genuine first time power up. Got the power supply, we're ready to go on the screen. So I've got my little button here to hold down to clear the CMOS, so 1. Oh dear. That's not good at all, is it? Slightly panicked there, it's still in reset. Okay, so I've put the reset pin away. There we go. Oh my god. Here we go. RISC OS booting into the desktop. And oh gosh. That is just the cable. It's got syncing issues. But there you go. That board's fixed. So I'll now find out exactly where that break was, but get on to clean the rest of it up. But at least I know it's not a lost cause now. Let's have a look at the floppy drive. It's Citizen drive. There we go, like that. There we go, like that. Nice, easy to get into. Oh, this hasn't been touched, has it? Look at that. I think this was skipped relatively on in its life. I can't believe the condition of it. You know, it's absolutely mint. I think what I'm just going to do now is what Gadget UK does, which is what I learned from there anyway, which is just get a cotton bud and a bit of isopropyl on the head. And this is about as far as my knowledge with floppy drives goes, to be fair. Clean it, and if it don't work, put a Gotek in. So I don't know if I've got you in shot there, but I'm just gently. I don't want to go mad on it because I don't want to damage it. If you're looking for how-to videos, these probably mine are not really the ones you want to be watching. Okay. This is how not to do it. This is how not to do it. Problem is, once it's greasy, you can't get any bloody purchase on it. I'm going to leave it at that. Just get rid of all the real load excess off of it. The keyboard obviously is filthy, and it's lost some of its conductive paint. So you've seen this before, but I'm just going to take this apart, and that's going to be by hopefully popping these plastic clips. No idea what's still got. Oh, maybe that guy. There we go. That comes off, and there's a little bit of fluff in there. I'm going to brush this off outside. Just gently set that down there for a sec. Give this a wipe over. Give this literally put it on a flat surface. Wipe it over with a damp paper towel, and then dry it. And that's the end of that. Wipe down the membrane and just going to let the little bit of primer dry overnight on the plate before I put it back. Till I go through like that. So there's the key. It's got a little captive spring in it. Absolutely filthy. This can be run under the bath, under the tap, a bit of fairy washing up liquid. And then all the keys are going to get washed individually with a baby wipe. Okay, there's the keyboard. So here's the back plate that we patched up yesterday. Make sure there's nothing underneath it. Clean up the LED legs with a little fiberglass pen, which is a trick I picked up from Gadget UK. Yellow one for the floppy, and the rest are all green. Okay, so just get a couple of clips in. So that's the keyboard largely done. Just got to deal with this damage here on the ribbon on one of them. This one's fine. This one is quite badly damaged. But before I do that, I want to go back to the main board and trace the actual break in that wire which we bodged with the jumper wire. I've got to try and trace that down, and also I'm going to remove this keyboard connector because it was ripping up the tracks on the keyboard ribbon. I'm going to see if it's possible to repair these because the replacements are not as good a quality. And what I've done here, you can see I've pulled one of these pins out. So what I'm doing is grabbing, I don't know if it's going to work or not, but grabbing them with the pliers and pulling out each pin like that. Because you can see, hopefully, I don't know if you can or not, but the pins here, they've got no real spring on them. They need more of a spring on them, and they need cleaning up. So I'm going to pull them out like that. It will grip the ribbon better. But before I do that, I'm going to clean up each of the front things here with the fiberglass pen, so it doesn't wreck the ribbon. So it's a bit of a painful process. And when it's serviceable again, Just going to put it back on the board here. So the two sort of silver bits face each other on these. Now the legs probably won't line up now because I've been screwing around with it. I've traced the break in the board and it's not where I was expecting it. Normally where these fail, because the battery is here, the damage comes here and it's the ROM tracks. And because it was an address line that was missing, I thought, oh, it's going to be in the ROM tracks. It basically goes all the way up the board up to here. I sort of tagged it there, then gone over the other side of the board, tagged it there, and then it runs all the way up here. And it went underneath this expansion connector, and I thought it was one of the pins on there, but it's not. It goes round it and up here. And this is where it should be joined to. So from there to there is joined, but from there to there isn't. The brake is actually here. See that little dot? It's like a little dot of acid. I'll show you under the scope. That was the damage. It was just under this connector here, and you can see it's just there, that teeny tiny, that was the brake. I'll show you it's fixed, but I think I'm going to leave a bodger wire on the back just because of where it is. People plugging stuff in and out of here, that's right on the join, and it could fatigue quite easily. So I think I'll put a shorter jumper wire on the back. But as we stand, we can now go from pin 8 here to pin 3 here. I've disconnected the jumper wire here. It doesn't go anywhere at the moment, just so while I was testing it. But I think I'm going to try and figure out a shorter run. Yeah, it'll probably be okay, but these are quite difficult to get things in and out of, and it's going to put quite a lot of strain on that connector. So I'll do that and come back, and then we'll put it in the case. Okay, so you can see we're all back together now. I haven't put the cover on the power supply because I'm still not happy with it. It's been creeping up, starting at a starting voltage of about 5.5 and going up to 5.9 unloaded. But I just want to do some more tests on that. What I'm going to do is I'm going to see whether the recap has affected the output. I'm also going to put it on a scope, see what the ripple's like. Once again, please don't power it up with a cover off the power supply. So here we go. So it's starting out at 5.4 volts. And it's climbing really quickly. Alright, we're pretty much bust on that, so I'm going to turn it off. Okay, now this is still live. I'm going to leave it there a minute, and I'm going to unplug this mic so it doesn't. Don't touch anything here. Don't know if it's still live. So you got point. I'm just taking the voltage on the bridge rectifier there. 0.25 volts. Double check. So I think the supply is safe. I'll just show you what it would be if it wasn't safe. Won't do this. See there? 347 volts. That's why you don't want to touch it. And turn it off. The dummy load set to 0.55. That's live. You set the thing to run. It's beeping because it's just under 5 volts. 50 millivolts for division, so It's not even that. That's working nicely. So it's crept over the threshold, which is why it stopped beeping. When it goes over 5 volts, it stops beeping. So that power supply is creeping up, even though it's under load. It's still creeping up. Okay, so we've got the dummy load set up again. You can see on the meter it's starting off at 5.45 again. Let's put it under load. 4.99, so those are matching. Let's give it 10 minutes, see how long it takes to creep. Okay, I'm not going to tear the arse out of it. That's 15 minutes. You can see that they're rock solid. When I put the whole thing back together, this won't go in. I've got the port off here and I've got it in some white vinegar. It's been in there for about 20 minutes. So that's a lot better. It was all blue in there before. But I'm just going to see if it now fits. I'm going to rinse it out in some isopropyl first. I found out why the mouse isn't working 100%, and I think what it was when I lifted these link wires, the left and the right are here and here, and they got 2 little traces here, and I think they've broken here. When I look at these traces, a lot of them are dark, so what I'm going to do is do a little bit more patch up work with the solder braid, scrape off the traces, repair them. So if we plug this in now, the mouse should work. Left, right, which wasn't working, up, down, button 1, button 2, button 3. This is the stuff that I used on the keyboard ribbon. You can see I've patched it up there, that was all eaten away. But over very short distances, it shows an extremely high resistance. I'll show you what I mean. Let's put this on 2K. This has been dried for 2 or 3 days now. 700 ohms just across about 5 mil. 600 ohms. Yeah, beat mode. Beat mode. That's the silver stuff. Let's see what the resistance is here on one that we did. This one here, for example. 70. Okay, maybe not. We might get away with it. Let's see what happens. So I'm going to plug this in. Doesn't work, which I suspect will be the case. I'll have to come back and redo these with the silver. Okay, well I guess that's me told, isn't it? It works perfectly. It must be because it's such a small distance it's having to patch. Okay, so I think that's pretty much a total fix. I've made a bit of a meal of it. What we got here? Spark plug. But back from the skip, here we go. Okay, thanks very much for watching. Hope you enjoyed that. Bit of an odyssey. Thanks for sticking with it for half an hour or so. Thanks very much to Gadget UK. Just a couple more things I'd like to do. I've obviously cleaned it all up and polished it and put it all back together and made it look lovely. I'm still not very happy with the fact the power supply is creeping up, and I'm probably being paranoid for no reason. But what I'm going to do is put one of these in line with the power supply. If you haven't seen one of these already, these are a Commodore 64 Saver, and they're made by a guy called Bwack. They will cut the voltage if it goes past, I think it's about 5.4 volts. The idea is that they protect all the chips on the Commodore 64. And what I'm going to do is fiddle the reference voltage. I'm going to try and set it at about 5.25 volts. We'll see how that goes. That might not work, but we'll see how that goes. But that won't be in this video. I'm going to put the 4 meg RAM expansion in it, and I'm going to give it a disc-on module. And then I'm going to knock up some of these. These are RTFM, which stands for what you think it does, joystick interfaces, and they will give it a port, or 2 ports I think, on the joystick for games. Thanks very much for watching. Take care, and I'll see you all soon.